Chapter 5. Making Colours. The Giant Cuttlefish. In the first chapter we met an animal hovering under a ledge in the ocean. As it hovered, it changed colours, second by second. An initial dark red unveiled patches of grey and silver veins. Blues and greens seeped back and forth on the arms. In this chapter we're back in the water with this animal and its ceaseless transformations. A giant cuttlefish looks like an octopus attached to a hovercraft. It has a back shaped a bit like a turtle shell, a prominent head, and 8 arms coming straight from the head. The arms are roughly like octopus arms, flexible and unjointed with suckers. When you're facing a cuttlefish, these arms can look like they're placed in a roughly horizontal array, but they're arranged around the mouth, and like an octopus's arms, they can be thought of as 8 huge and dexterous lips. Tucked away near the mouth are 2 longer feeding tentacles, which can be whipped out to seize prey. The mouth itself contains a hard beak. A cuttlefish body has no spine or real bones, but there is a stiff cuttle bone, which looks like the inside of a surfboard, inside the shield-like back. The shield is fringed by a skirt-like fin, a few inches wide on each side. A cuttlefish moves slowly by undulating these fins. When it wants to move quickly, it uses jet propulsion with a siphon underneath the body that can be pointed in any direction. Most cuttlefish are small, measured in inches, but a giant cuttlefish can grow to 3 feet long. This animal is 3 feet long with a skin that can appear just about any colour at all and can change in seconds, sometimes much faster than a second. Thin silver lines wander over its head as if the animal is visibly electrified. The electric lines make the cuttlefish look like a hovering spacecraft. But the disruption to one's impressions, to all attempts to make sense of the animal, is continual. As you watch, bright red trails lead from its eyes. A spaceship crying tears of blood. Cephalopods in general, not all but a great many, are skilled colour changers. In this prodigious group, giant cuttlefish are perhaps the pinnacle, or at least the most colourful. Some degree of colour change is not rare in nature. Many animals can modulate their surface colour to some extent. Chameleons are the familiar example. But cephalopods are faster and produce a wider range of colours. In the case of large cuttlefish, the entire body is a screen on which patterns are played. The patterns are not just a series of snapshots, but moving shapes like stripes and clouds. These seem to be immensely expressive animals with a lot to say. If so, what is being said, and to whom? The giant cuttlefish is also remarkable in another way. How disarming it is to find friendliness in a large wild animal. I do not mean a mere toleration of a human's presence, but an active engagement, the animals making contact with a foreign being. This is not routine in giant cuttlefish, but not rare either. Quite often you encounter a friendly curiosity. The animal comes forward with its skin in a quiet resting pattern of colours and shapes. The cuttlefish will hover close by, apparently trying to work you out. These are little studied animals. They've not been kept in captivity very often. Alexandra Schnell, one of the few people to study them closely in the lab, says that they do show hints of the same complex responses to captivity seen in octopuses. They ambush visitors with well-aimed squirts of water from their jets. But giant cuttlefish seem even more enigmatic and otherworldly than their octopus relatives. They have big brains, both in absolute terms, sheer size, and as a proportion of body mass. As far as I know, they've not shown the most striking marks of intelligence seen in some octopuses, puzzle-solving, the use of tools, the exploration of objects. But they've not been studied nearly as much, and their lives would seem to make such behaviours less useful than they are for octopuses. These are not clambering explorers, but swimmers. While giant cuttlefish might not have the protean inventiveness of the octopus, they do have features that stay with you long after you've been around one in the sea. The friendly curiosity, at least in some cases, or a wary engagement as they hover toward you and away. And those unending, astounding colour changes. Making colours. The skin of a cephalopod is a layered screen controlled directly by the brain. Neurons reach from the brain through the body into the skin, where they control muscles. The muscles, in turn, control millions of pixel-like sacs of colour. A cuttlefish senses or decides something, and its colour changes in an instant. Here's how it works. The skin has an outer layer, a dermis, that acts as a covering. The next layer down contains the chromatophores, the most important of the colour control devices. A single chromatophore unit contains several different kinds of cells. One cell holds a sac of a coloured chemical. Around it are muscle cells, 1 or 2 dozen of them, which pull the sac into different shapes. Those muscles are controlled by the brain. They stretch the sac to make its colour visible, or relax it for the opposite effect. Each chromatophore contains just one colour. Different cephalopod species use different colours, and usually the animal has 3 kinds. In a giant cuttlefish, the chromatophores are red, yellow, and black-brown. Each is much less than a millimetre in diameter. This device explains how cephalopods produce some of their colours, but not all. A giant cuttlefish can make red or yellow by activating chromatophores of one colour alone, and it might make orange with a combination of the two. But this mechanism has no means to produce many other colours a cuttlefish might display. There's no way to produce blue, green, violet, or silver-white. Those colours are produced by mechanisms in the next layers of skin. Here we find several kinds of reflecting cells. These cells do not display fixed pigments as chromatophores do, but reflect back incoming light. This reflecting need not be a simple mirroring. In iridophores, light is bounced and filtered through tiny stacks of plates. These plates separate and direct the light's different wavelengths, shining back colours that can be different from those that came in. The results include the greens and blues that chromatophores cannot produce. These cells are not attached directly to the brain, but it seems that some of them are controlled more slowly by other chemical signals. Just below the iridophores, the leucophores are another kind of reflecting cell. They do not manipulate the light, but reflect it straight back. As a result, they often appear white, though they can reflect whatever colour is around. As the chromatophores sit in a higher layer than the reflecting cells, all the reflecting cells have their effects modulated by what the chromatophores are doing. When chromatophores expand, this affects the light that makes it down to the reflecting cells, and hence what is shone back. Imagine looking at a cuttlefish's skin from its side. In a cross-section, we would see a top layer, then a layer with millions of tiny coloured sacs, each being pulled constantly into shapes that expose or hide the pigments inside. This will be happening at a great rate through the activity of many muscles. Some light would pass through this layer and reach another layer where it would be reflected and filtered between stacks of mirrors. Those cells might be changing their shape more slowly as chemicals reach them from elsewhere. Further down, a layer of simpler, reflecting cells mirror back whatever light reaches them. Suppose a cuttlefish has about 10 million chromatophores. Then, very roughly, we can think of that layer of the animal's skin as a 10-megapixel screen. Roughly, I said. Both because the pixels seem not to be controlled entirely independently of each other, but in local clumps, and also because each chromatophore has just one colour. Some of the pixels are also on top of others, so the same patch of skin can produce many different colours. The layers below the chromatophores then add more complexity. The cephalopod's coloured layers are thin and fragile. Cuttlefish look very different when they've lost skin through age or damage. Then you see dull white patches. The magic skin is a thin sheet on top of a plain white body. On the animals I watch, Reds are in some sense the base colours, the most commonly seen. These reds range from maroon to fire engine. A common decoration on top of the red base is a white silver as it appears underwater. The whites form veins and dots, making little jagged flashes or a line of pearls. Other colours appear in patches, yellows, oranges, olive greens. They may hold static patterns, but their colours are rarely fixed for long. Their dynamic patterns are like movies played on the screen of the cuttlefish's skin. An example is the passing cloud display. Alternating waves of darker and lighter patches move consistently along the body from front to back or back to front. Once I watched a large cuttlefish from above and saw the left side of its body displaying a passing cloud to another cuttlefish under a rock, while the right side was still and camouflaged, pointing out to sea. Cuttlefish's colour changes often occur in combination with changes to the shape of their body and skin. Sometimes they swim around with dozens of papillae or folds of skin sticking straight out from their back. These look like tiny versions, an inch or so high, of the plates on the back of a stegosaurus. These papillae have nothing hard inside them and can be produced in a second. The eyes are the sites of finely detailed modifications in skin shape. Many cuttlefish produce thin wisps and folds of skin above each eye. These look like carefully sculpted eyebrow extensions. At rest, the 8 arms of a cuttlefish hang down in front and look fairly similar to one another. A cephalopod's arms have been assigned numbers from 1 to 4, left and right. Starting at the top, there are arms left 1 and right 1. From the front, these look like inner arms. Outside these are arms left 2 and right 2, then the 3rd pair, and finally the 4th. In giant cuttlefish, the 4th arms are larger in males than in females. When showing aggression, males will often flatten their 4th arms into shapes like broad blades. Another aggressive gesture is to hold the 2 first arms up like horns. Some cuttlefish make these horns elegantly wavy. Others shape their arms into fiddleheads, hooks, or clubs. In the most elaborate cases, cuttlefish will arrange layers of arms at 3 or 4 different levels. The first arms will be held high and straight, the second arms will be horn-like at a lower level, perhaps with curled ends, with the 3rd pair below, and finally the 4th arms, flattened and made as massive as possible. There are some fish whom, despite their harmlessness, giant cuttlefish seem to positively despise, and their approach is generally greeted with arms raised into horns and hooks. All these behaviours vary across individuals. I've sometimes been able to recognise an individual over many days, occasionally over a week. It's not easy to re-identify animals who can change their entire colour and shape at will, but sometimes a distinctive scar makes this possible. Eventually, I also learned to treat some white markings on the skirt-like fin, which seem to be permanent, as a kind of fingerprint. Different individuals respond differently to me, though they're of the same sex and size, and in the same place at the same time of year. The most welcome style of interaction is the curious friendliness I mentioned before. Some individuals tend to come forward in a resting pattern of colours and watch closely. The friendliest of them have reached an arm forward to touch me. This is quite rare. The cuttlefish hovers, moving slightly with his fins or invisible jet. As we hover, he maintains a specific distance, edging back when I edge forward, and sometimes forward when I edge back. But eventually he lets the distance narrow until our bodies are only a few feet away. I move a hand out close to his arms, but do not touch them. The cuttlefish reaches the tip of an arm or 2 out to touch mine. Nearly every time this has happened, it has happened only once. After a brief touch, the cuttlefish shifts back to maintaining a few feet of distance. He was interested enough to touch, but having touched once, he returns to where he was. One possible interpretation of this action is that the cuttlefish is seeing whether I might be good to eat. But a person is much larger than a cuttlefish, whose usual foods are crabs and fish caught whole. I don't think they're interested in me as lunch. Some individuals, friendly or not, have distinctive styles of colour change. I've occasionally encountered cuttlefish who seemed to produce colours the others had not quite thought of, or patterns with particular brilliance. The first of these I named Matisse. He was a friendly cuttlefish I visited for several days some years ago. All his colours had particular detail, but something else set him apart. He would be hovering without fuss in some mixture of reds and whites and would suddenly explode into bright yellow. This flood covered his entire body with no other marks visible and would be switched on in less than a second. One moment he'd be dark red with veins and stripes, and in less than a second he looked like a cuttlefish-shaped sun. The flare would then fade more slowly. Oranges would appear among the yellow and darken. Patterning would return. In 10 seconds or so he was dark red again. The change to yellow was not accompanied by raised arms or other displays. There was no other sign of fuss. I've seen overall yellow described as a sign of alarm in other cephalopods. I suppose it's possible that Matisse was alarmed, but why did everything else about him look so calm? Occasionally he produced yellow patterns in response to intrusive fish, but these were deeper yellows combined with arrangements of arms. The uniform blazes of canary yellow I saw appeared to be part of a different behaviour. He just seemed to have a liking for these chromatic explosions. In the years since, I've seen quite a few other cuttlefish who produced these yellow flares, though none who lit the water up quite like Matisse. Given what I said about the machinery of colour change, it's easy to work out how this is done. A giant cuttlefish has some yellow chromatophores, so the flares were almost certainly produced by expanding suddenly those chromatophores and scaling back everything else. Well after Matisse had come and gone, a cuttlefish arrived whose displays were beyond anything I've encountered. The only suitable name for him was Kandinsky. Kandinsky had fixed habits and a definite home. Unlike Matisse, he did not have a single notable colour. He produced the same kinds of patterns and colours that the others did, but in a more extravagant way. For about a week in 2009, when I was trying to get the perfect photograph of him, I would visit him in his home. I'd arrive in the late afternoon each day and wait at the surface above his den, which was about 12 feet down. He would eventually emerge and come up to man the top of his rock, facing out to the ocean side. He held 2 arms aloft, with the others roaming about below them. I would swim down to meet him. When I arrived, he would have arms going everywhere, like a collection of ceremonial lances. Sometimes he would knot a couple of arms together over his head. Raised arms are often a sign of agitation and sometimes hostility, but I don't think this was true of Kandinsky, as he tended to produce such elaborate shapes continually, even when I was a fair distance away. On his skin, Kandinsky favoured flaring mixtures of red and orange, including a kind of pale orange-green, and he often combined these colours with the passing cloud display, in which waves of dark shapes flow over the skin. Tear-like patterns moved down a pair of his inner arms. After hovering in the water near his favourite rock for a while, he would set off to tour the shallows. He was not one of the friendly cuttlefish, but he would allow me to follow closely as he roamed in loops through the reefs around his den. While some cuttlefish seem friendly and curious, a second style of response to an exploring diver is intense hostility. Fortunately, this is rarer than friendliness. The most spectacular case I remember was an encounter with a large male cuttlefish in a spot where some very friendly ones have lived. Whenever I turn up at that rocky ledge, I'm reminded of those amiable meetings. This time I found a perfect expression of animosity, choreographed in colour and shape. I arrived and saw first a swirl of arms under the rock ledge. The arms were yellow-orange-brown. The animal was facing out, surrounded by waving seaweed, with arms going everywhere. I thought initially this behavior might be camouflage, that his waving was matched to the seaweed. I came closer and found him producing more colours, silver-white welts. These were not the relaxed pulsations of silver around the face and arms that are common, but larger blotches that would flare on and off. His lower arms were fanned out below, and the other arms were a forest of horns. He was instantly watchful, and very soon he was coming out at me fast. I swam backward in a hurry. He kept coming for some distance and then left the chase and returned to the den. I waited and then approached cautiously again. Out he came like a jet-propelled medieval siege device. On these chases he produced the most murderous-looking displays I've ever seen. Burning orange colours, arms like horns and sickles, and skin folds resembling bent iron armour. Sometimes his inner arms were held high, contorted. At one point he held nearly all his arms aloft and twisted together, with just one set of arms below and his face between. I thought, he looks like the jaws of hell. It was as if he, in his molluscan way, had a real sense of what is frightening for a human and was trying to produce a vision of damnation, something intended to strike at our hearts. I persisted with him and kept cautiously returning. He continued to chase me off, but I soon noticed that these charges never quite reached me, and this remained so when I began to retreat more slowly. I wondered how much bluff there was in his advances and how much genuine violent intent. Eventually I tried a new tack. If he is waving his arms murderously at me, why not wave back? The next time he came out, I retreated much less and lifted my arms in front of me, with scuba gear going everywhere. That got his attention. He still made as if to come forward, but did not actually move much, and the flailing arms began to calm down. He reduced his displays more and more, and soon his arms were at rest, and the spiky skin folds receded. I was finally able to come close to him. He stopped facing straight at me and seemed to be looking at an angle, off over my shoulder, much more relaxed. Once I moved directly in front of him, and he suddenly came at me again, his head lowered at first and then roiling with arms. I decided that we'd become as friendly as we were going to get. There is another notable mode of human-cuttlefish interaction, though interaction's not quite the right word. Some cuttlefish behave with a level of indifference that is so intense it is hard to describe. In some ways, this is the most intriguing behavior. These cuttlefish do not seem to register you as a living being at all. When they're still, they tend not to face a person directly, as others quite often do, but look off past one's shoulder. If you move a little, they adjust too. There's a maintenance of the non-contact. This profound indifference is seen in some cuttlefish as they go on looping excursions around their reefs. On these trips, a cuttlefish might poke around under rocks or just wander about. Much of the time they're probably looking for food or mates, but they often do not seem to be looking very hard. Touring cuttlefish can sometimes be friendly, or at least curious, stopping to peer at you before swimming on, but some are able to ignore you no matter how close you swim, even if you're right alongside their eye. Once I was being ignored so perfectly that I planted myself directly in the animal's path just to see what he would do. What followed felt like an existentialist game of chicken. He came closer and closer, refusing to acknowledge my presence until he was just a foot or so away. Then he looked up at me with an expression that I cannot describe at all, except to say that he seemed deeply unimpressed, edged past, and swam on. What role do we have, then? What are we to them? Surely we are registered as large, mobile creatures. Surely then we might be potentially dangerous, or at least something of interest. Other cuttlefish do see us that way, as visitors to study or to chase off with a wild display. But sometimes it appears that we do not come across as living beings at all. Being ignored so deeply makes you wonder if you're entirely real in their watery world, as if you're one of those ghosts who does not realize they are a ghost. Seeing colours. With our picture of cephalopod colours nearly complete, we now reach a fact that makes absolutely no sense. Cephalopods, in almost all cases, are said to be colourblind. This impossible conclusion is based on both physiological and behavioural evidence. First, any system for detecting colour differences requires something in the eye that can distinguish differences in the brightness of light from differences in its colour. The usual way this is done is to have several kinds of photoreceptors. Photoreceptor cells contain molecules that change their shape when they are hit by light. The change in shape triggers other chemical events in the cell. Photoreceptors are the interface between the world of light and the signaling network of the brain. Any eye must contain something like this. For colour vision, you need to have a range of photoreceptors that respond differently to the different wavelengths of the light that comes in. Most humans have 3 kinds of photoreceptors. Colour vision, using this system, requires at least 2. Most cephalopods have only 1. Behavioural tests have also been done on some species. Can a cephalopod learn to make a distinction between 2 stimuli that differ only in colour and in no other way? Apparently the ones that have been tested cannot. This is baffling. These animals are doing so much with colour. They're also superb at matching the colour of their surroundings for camouflage. How can you match colours you cannot see? Biologists sometimes offer explanations along these lines. First, cephalopods may be using subtle differences in brightness as indicators of the likely colours, hues of objects around them, given the typical colours in their environment. Second, the reflecting cells, the mirrors in the skin, can help. You can produce a colour you cannot see by reflecting it back from outside. This makes sense of some of what cephalopods can do. Camouflage can be achieved with reflection, if the colour you aim to match in your background is also coming towards you from other directions. Simple reflection cannot be the explanation if an animal is matching a colour behind its back, while the light coming in from the front is different. In that case, the cephalopod would have to actively produce the right colour through some combination of chromatophores and reflecting cells, and it would have to know which colour to produce. Cephalopods do seem to be able to do this. They often seem to match a colour that is behind them when different colours are in front.